Welcome to Fuzzy Mathematics, the Basics. In the previous lecture, we have talked about the relations between fuzzy sets. In this lecture, we are going to talk about three types of operations on fuzzy sets: the union, the intersection, and the complementation. First, let's record these operations on crisp sets. Let A and B be two sets. The union of A and B is the set containing those elements that are either in A or in B or in both. An element X belongs to the union of A and B if and only if either X belongs to A or X belongs to B, or both. Next, intersection. The intersection of A and B is the set containing those elements that are both in A and in B. An element X belongs to the intersection of A and B if and only if X belongs to A and X belongs to B. Next, complementation. The complement of A is the set of the elements in the universal set that are not in A. Sometimes the complement of A is also called not A. We can also consider the union and the intersection of an arbitrary number of crisp sets. For example, we use this notation to denote the intersection of A1, A2, all the way up to Am. And we use this notation to denote the intersection of A1, A2, all the way up to Am. We use this notation to denote the union of A sub I equals 1 to infinity, and we use this notation to denote the intersection of AI, I equals 1 to infinity. More generally, if I is an empty set, the element I is called identifier or index, and set I is called the identifier set, index set, or identification set. This notation is used to denote the union of all these AI. The union is taken over all the identifiers, and this notation is used to denote the intersection of all these AIs. The intersection is taken over all the identifiers. The union of a collection of sets is the set that contains those elements that are members of at least one set in the collection. The intersection of a collection of sets is the set that contains those elements that are members of all the sets in the collection. Again, we noted that each crisp set is characterized by its characteristic function, and each fuzzy set is characterized by its membership function. If we can express these operations with their characteristic functions, and we extend the characteristic functions to the membership functions, then we can define the corresponding operations on fuzzy sets. Let A and B be two sets. K sub A and K sub B are their characteristic functions, respectively. Let's start with complementation. How to express the complement of A with the characteristic function of A. Suppose X is in A, K sub A of X equals 1. By the definition of complementation, X is not in the complement of A, so it's going to be 0. On the other hand, suppose H is 0. X is not in the complement of A. That is, X is in A, so K sub A of X is 1. Suppose X is not in A, K sub A of X is 0. By the definition of complementation, X is in the complement of A, so it is going to be 1. On the other hand, suppose this is 1, that is, X is in the complement of A. X is not in A, so K sub A of X equals 0. This is 1, this is 0, this is 0, this is 1. What does that mean? That means chi sub the complement of a of x equals 1 minus chi sub a of x. Next, the union. How to express the union of a and b with their characteristic functions. Let's look at the table. Suppose x is in the union of a and b. The characteristic function of the union of x is 1. By the definition of union, x is either in a or in b or in both. That is, either chi sub a of x is 1 or chi sub b of x is 1 or both. Suppose x is not in the union of a and b. The characteristic function of the union of x is 0. By the definition of union, x is neither in a nor in b. That is, chi sub a of x is 0 and chi sub b of x is 0 too. The characteristic function of the union of x is 1, as long as one of the two is 1. The characteristic function of the union of x is 0, if and only if both of the two are 0. What does that mean? That means the characteristic function of the union is the maximum of the two. Let's check. The maximum of 1 and 1 is 1. The maximum of 1 and 0 is 1. The maximum of 0 and 1 is 1. The maximum of 0 and 0 is 0. So, the characteristic function of the union of x is the maximum of chi sub a of x and chi sub b of x. Next, intersection. How to express the intersection of a and b with their characteristic functions. Let's look at the table. Suppose x is in the intersection of a and b. That is, the characteristic function of the intersection of x equals 1. By the definition of intersection, x is both in a and in b. That is, chi sub a of x is 1 and chi sub b of x is also 1. Suppose x is not in the intersection of a and b. The characteristic function of the intersection of x is 0. By the definition of intersection, x is neither in a nor in b. That is, either chi sub a of x is 0 or chi sub b of x is 0 or both. The characteristic function of the intersection of x is 1 if and only if each of the two is 1. The characteristic function of the intersection of x is 0 as long as one of the two is 0. What does that mean? That means the characteristic function of the intersection is the minimum of the two. Let's check. The minimum of 1 and 1 is 1. The minimum of 1 and 0 is 0. The minimum of 0 and 1 is 0. The minimum of 0 and 0 is 0. So, the characteristic function of the intersection of x is the minimum of chi sub a of x and chi sub b of x. Wait a minute. What about multiplication? Let's check. 1 times 1 is 1. 1 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. In fact, there exist different methods to extend the operations on crisp sets to the fuzzy cases. Here we choose maximum and the minimum, and we will discuss some of the others later. Now we have the following theorem, Theorem 1. Let A and B be two sets. The characteristic function of the union is the maximum of the two. The characteristic function of the intersection is the minimum of the two. And the characteristic function of the complement is 1 minus chi sub a of x. Here we have used the symbols. we use this symbol, join, to denote the operation of taking maximum of the two numbers. And we use this symbol, merge, to denote the operation of taking minimum of the two numbers. We can also have the following theorem for the union and intersection. Theorem 2. Suppose I is an identifier set. AI is a crisp set for all I. Then the characteristic function of the union of X is the maximum of these numbers. The characteristic function of the intersection of X is the minimum of these numbers. By the way, the algebraic structure consisting of the sets 0 and 1, together with the three operations, the join, the merge, and complementation, we mentioned here, is a Boolean algebra, which we will discuss later. Now we have expressed these operations on crisp sets with their characteristic functions. What's the next step? Replace these characteristic functions of crisp sets with the membership functions of fuzzy sets. Then we get the three operations on fuzzy sets. Let A and B be two fuzzy sets. First, the union. The union of A and B is denoted by this notation, where the degree of membership of element X in the union of A and B is the maximum of mu sub A of X and mu sub B of X for all X. Next, intersection. The intersection of two fuzzy sets A and B is denoted by this notation, where the degree of membership of element X in the intersection of A and B is the minimum of mu sub A of X and mu sub B of X for all X. Next, complementation. The complement of a fuzzy set A is denoted by this notation, where the degree of membership of element X in the complement equals 1 minus mu sub A of X. Similarly, we can also consider the union and intersection of an arbitrary number of fuzzy sets. Let I be an identifier set. The union of AI is denoted by this notation, where the degree of membership of element X in the union is the maximum or supremum of mu sub AI of X. And we still use this symbol, join, to denote the operation of taking maximum or supremum of these numbers. The intersection of AI is denoted by this notation, where the degree of membership of element X in the intersection is the minimum or infimum of mu sub AI of X. And we still use this symbol, merge, to denote the operation of taking minimum or infimum of these numbers. In this lecture, we have talked about three operations on fuzzy sets: the union, the intersection, and the complementation. Next time, we are going to do some examples of this operation. Thank you.